Alright, so we have this question. Find the smallest divisor given a threshold. So, given an array of integers nums and an integer threshold, we will choose a positive integer divisor, divide all the array by it. Wait, is it divisor?
Divisor.
Divisor. Yep. Alright, so given an array integer of numbers, nums and an integer threshold, we will choose positive integer divisor. All the array by it and some divisions result. Find the smallest divisor such that the result mentioned above is less than the or equal to threshold, and each result is rounded to the nearest integer greater than or equal to that element. For example, 7 divided by 3, so 3, 10 by 2, it's 5. So basically what we need to do is that we need to take the array nums into consideration, and then we need to divide them by a few numbers, and those numbers will be the output. So we need to make sure that after division of each element, the sum of their answer or the question has to be less than or equal to threshold. Like for example, if I divide 1 by 5, I will be getting 1 because that will be 0.2. Yeah, that will be 0.2. So we need to take that is rounded to the nearest integer greater than or equal to. So nearest integer to 0.2 is 1. We can't take 0 because it's less than that. So yeah, 5, it will be giving 1 for this, same 1 for this, also 1 for this. For this it will be giving 2, because obviously 5 2s are 10. So like if we divide 9 by 5, so we will be getting 1.8 something, so to the nearest, so it becomes 2. So yeah, so basically what we have to do is, this question is binary search, that's why I picked it. Wait, topics, yeah, array and binary search. So what we can do is that we can this is not for this, yeah. So what we can, actually we can start the time, yeah. So what we can do is that we can first of all look for the division case, look for the maximum number, and because the loop will be running from 1 to 9, all right, because yeah. So I mean what we can do is that we can look for the maximum number, till that the loop is going to be running a binary search. We can look for the division and everything, taking the ceil values using that math.ceil. For the max one we can use math.max. Yeah, we can have the maximum, we can have the ceil value, and yeah, let's start. So alright, let's make our the thing, like let's enter the main. We will be needing to create like two functions extra, because we need a ceil and we need a maximum, so we need to handle those cases. So let's start with binary search, not declaring anything, just writing the code as it is. Low less than equals to high. While low is less than equal to high, what do we have? Is it recording? Yep, it is. Hello. Yep. So while low is less than or equal to high, we can have our int mid, that can be low plus high minus low by 2 if 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 so we need to see that what do we need to compare. We can have a maximum that can be used as an high, like till that point the loop will be running. Yeah, that can be the maximum thing. So here we use the maximum. Where do we use that ceil thing? So in binary search we need a target, you know, we don't have a target right here, so we can use that ceil thing as a target. So what we can have is let's call that function ceil for the moment, and how do we call, like, int what can be the name of it? Like, if the nums is the input, threshold is 6, what do we need to like compare? Like, we have the mid, but now we need to compare mid with something. Like, let's make it xyz or something, and then say then we'll call our function that is ceil. Yeah, let's keep it for like this for the moment. Now let's work on the conditions. Working on the conditions, what we can do is that we can be like we need to divide and then add all of them. So if the divisor is 1, if the divisor is 4, and the divisor is 5, so that divisor thing I can think of handling that going from 1 to 9. Alright, going from 1 to 9, giving the threshold to be like getting the threshold as 6. Alright, let's create that ceil function for the better understanding. Int ceil, what will it take as an input? What will it take as an input? What can be taken as the input right here? I can take the nums, int nums the array. Alright, int nums the array, and like I need to pass this right here, so I need to have that value that can be mid for us, I guess, you know, like nums the array and mid. So what it will be doing is that it will be like not mid right here, it's gonna go here, but like some int can be here. I don't know what that int will be. That will be mid for this moment, obviously. So what that int is gonna do, we need to iterate from here to here. Yeah, now we'll have a mid. Alright, like 0 1 2 3, so 0 like 3 by 2 with like 1, 0 1, this will be the mid. Alright, so now what we need to do is that we need to figure out that going from left, like handling a middle one, we need to see that when we divide, you know, like, alright, let's write that down, like that division part. So like having an int answer set as 0 initially, int answer is 0, and then for like iterating over the nums array, for int I equals 0, I less than n, that is nums length, int n equals to nums dot ngth length, yeah, and then I plus plus. So iterating over all of them, what we can do is that our answer can be uh, our answer can be math dot seal, is that the right spelling? Math dot seal in Java. Yeah, that's the right spelling. So math dot seal, and then we will in this be taking double what do we have, so we need to divide here. This int h is going to be the mid, so we need to divide that. So double, no, but we need to wait, yeah, we need to divide the elements, yeah. Double nums I divided by double h. All right, so whatever we take from 1 to 9, whatever the number is going to be from 1 to 9, it will be under that 1 to 9, it won't be exceeding that. All right, so it's not like it's gonna go further from 9 or something. So it's like we can take from 1 to 9, what we can do is like nums I 1 is being divided by h. So here in this case the h is the mid right here. So this middle element, like suppose it lands on 2, so now we will be checking. So now when it lands on 2, so what we will be checking is that 1 divided by 2 is going to give 1, by 2 is going to give 1, by 5 is going to give 3, and for 9 it's going to give 5. So that's how we'll be checking and we'll be adding them. Alright, so when we divide it and then we keep adding them, yeah, we keep adding them. So we divide, we add to the answer, we divide, we add to the answer. So yeah, our answer is sorted. So what we need to return from this is return answer. Yeah, return answer. We'll be returning answer from this. Fair enough. So now let's put the seal thing in it. Nums and your mid, your nums array and your mid for this. Yeah, I guess fair enough. But let me initialize int low equals to 1 and int high equals to max nums. Yeah, maximum out of the nums. So we'll be creating that function. Let's create that as well. Int maximum, int maximum. We'll be taking int nums. That's it. Out of the nums we need to find that. So considering we have our max, but here we have our int max as what do we have our int max as? Let's take it to the least possible value, I would say. Yeah, least possible value, what that can be. Integer dot min underscore value. Yeah, in Java we take it like that. So now like for int I equals 0, I less than n, I plus plus, what do we have? We have our int max set to the minimum value. So what we can do is that we can have our max as math dot max, in which we can have the comparison. we can have the comparison of nums I and max. Yeah, fair enough, I guess. Yep. And then we can return max. Yep, I guess works. Yes. So we have our maximum maximum, and then we have our nums I in it. So yeah, so that's how our high is gonna be. So from low to high and everything, we have our seal and we have our everything. So what we need to do is that we need to find out that if so now the thing is that when we have our seal element, so what seal element is going to do is that it's going to divide from the middle, like it's going to divide every element by the middle element we have. So every element is going to be divided by the middle element that we have, and it's going to add it together. So that's what we need to divide every element by some element. From using binary search, we can have that as middle element. We need to divide every element by the middle element, like here in this case, and then like after dividing we need to add. So that is being handled by the seal. So now what we need to do is we need to, in binary search, what we do is we eliminate the parts that we don't need any further. Like suppose if middle is coming on 2, alright, if middle is coming on 2 and we divide and we get the answer more than, like the threshold reaches like above 6, it's greater than 6, means no use to go into the left hand side, because we have 1 over there, and that is going to give way more than what 2 did. Like here we have 17. So yeah, so if 2 is gonna give like 1 1 and for this 2 2s are 4, so 3, so that's 5, and for this 2 4s are 8 5, so yeah, it's gonna give 10. Yeah, I guess if I have the counting right, I didn't forget anything to add. Yeah, it's gonna give 10 or something. So that's gonna be more than 6. No use to, no use for us to move towards the left hand side, because 1 is gonna give 17. Move to the right hand side. So what we're gonna do is that we're gonna check that how to compare that. How do I compare that? Int xyz. Alright, so we have our threshold over there. So if xyz is greater or equal to threshold, yeah, so if xyz is greater or equal than threshold, what we can do is, if xyz, that's the total, if it's greater than the threshold, we can move towards the right hand side, obviously. So low can be mid plus 1, yeah, else what we can do is move to the left, like left hand side, if the else case is there. So if it's like xyz is less than equal to threshold, so high can be mid minus 1. Alright, how about that? So now the point is, what do we return? Like what do we return? Yeah, so like if you are starting from low and from high, yeah, the loop is gonna go till low to high. Yeah, so there will be a point wherein, like for example, if all the numbers right here were giving us the answer, like like suppose we have a distinction between them, 1 and 2 won't be giving the answer, but 5 and 9 can be giving the answer. And answer, what do I mean? The question needs us to give the solution in less than the threshold. Alright, threshold is 6. Yeah, we could have used 9. What could have we gotten is 1, like, yeah, 9, yeah, 1 1 1 and 1 4. So threshold is 6, so we are good in 4. But what it wants us to do is that it wants us to find the smallest divisor, not the, like 5 is then also available in the sequence, which is giving us till out like 5, so it's less than the threshold, but yeah, we need to find the smallest one. So out of 5 and 9, what's smallest? 5. Both of them are working very well. Like 9 is also working very well. It's giving us, I guess, yeah, 4 as the output, but 5 is giving 5 as the output. So both are accepted compared to the threshold, because they both are less than that, but we need to find the smallest one. So in terms like like these two elements won't be giving us anything, and 5 and 9 will be giving us something. So the thing is, like, what do we return right here? Like after this loop ends, like the low and high will be at some position, so we need to look out like what to return, because they will be at certain position. They might be at 5 or 9, like I don't know. We can try run and figure that out, but what can we return out of them? So if low starts from here and high starts from here, middle is this. Now in this case we move ahead, so middle plus 1, now this becomes start and this becomes end. So now the middle element comes to 5, and then now 9 becomes like high equals to middle minus 1, so 9 comes at 2. Alright, 9 comes at 2. What did just happen? Loop breaks, answer here 5, because the start was at the low was at 5. So what should we be returning? Should be low, because 9 like shifted the index, like 9 came on the left hand side of the 5, so that means the loop breaks. Alright, loop is gonna run till the time low and high are equal. 9 went that side, so looking at this case, our answer lies on 5, and that is on the low at the moment. So let's try to return low. Alright, let's see how it works. My bad. What's n? Wait a second. How about now? Oops. 45 expected 44. Why? Alright, good thing to now figure out that where is that plus 1 happening. Is it because of this? Nope. Let's keep it like at 1. Why is it happening then? Where is the issue in this code? We have our maximum number. It works for this case. It doesn't work for this case. Why? Alright, let's try to dry run it. Alright, let's verbally do that. So threshold is 5. So now what we do is that we take low as 1, and we take high as the maximum number. Maximum number is like 44 right here. Alright, so while the time low is less than or equal to max, yeah, what we do is that we take middle of it. Low plus high, 44, like 45 divided by 2, 20 to 2 is a 2. Why is output out 45? What if I return? I don't think so it's gonna work, but what if I return high? Oh wow, it works for this. Yeah, expected output and everything. Yeah, where's that plus 1 and minus 1 happening? Let's keep it high. Alright, let's keep it high. Let's make this that. Yeah, wrong answer. It doesn't matter. Low, mid plus 1, mid minus 1, blah 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 blah. What can be causing the error? Let's keep low as 1. Let's keep this as low, run. Opposite is gonna happen. Case 1 is gonna pass. Yeah. Let's figure that out now for this case. Alright. So low is 1, high is 44, it becomes 45. When you divide that by 2, 45 divided by 2, 2 is a 4, 2 is a 4, it's gonna get 22. So 22 becomes the medium. So yeah, 22 becomes the medium. So this is the medium. Alright, this is the medium. So now xyz is basically the seal, that is the value of xyz is nums and mid. So nums and mid, what's that doing? What's that doing right here is that it's dividing every, so 22 by, so it's gonna give us 2, 1, that's 3, then that's again 2, that's 5, then again 1, that's 6, then again 1, that's 7. So it's giving us 7. We don't need that, we need 5. Alright, we need 5. It's giving us 7, we need 5. We move. So now what's the case? xyz is greater than the threshold. Low equals to mid plus 1. Yep. So low becomes mid plus 1. This. Yeah. Is it because of the indexing or something? Like, I don't know. I guess it's because of the indexing or something. Wait. High is maximum nums. Wait. Nope, makes no sense. My bad. It's not gonna be like the. Wait. Yeah. There's nothing as such as 44th element. So no. Nope. Not gonna work. What's gonna work? Threshold is something. XYZ is an int. Low is at 1. My bad. Low is at 1. High is at this place. When we take out the mid, that comes out to be, yeah, 45. This 20, 22 is the mid. Yeah. 22 is the mid. We do that, we get 7. We need to now go low equals to mid plus 1. So low equals to mid plus 1. So mid plus 1. So in, alright, so mid plus 33, yeah. Do that shit again. 33 plus 44. 33 plus 44 is 77. Divided by 2. That gives us 2 3s are 6. 2 8s are 16. 38. 38. We don't have that. Alright, so seal divides that, but 38, like it's gonna be like 2, then we have 1, it's gonna be like 1, so 2 1 1, it's gonna be, it's 4. Wait, what's happening? Threshold has to be 5. If the divisor is 4, we can get the sum as 7. So the sum has to be 5, and this is the divisor. So basically there is nothing wrong with the array. The thing is that the divisor has to be this, and the loop is working fine. The return value is like +1. Why is the returning value +1? I can't have this low as 0 because it won't be starting within 0. I guess there's something like here only. Should I be taking generic formula? No, obviously not. Yeah. So the thing is, the loop is working fine. The loop's working fine. It's like, but it's just returning +1. Why? Where is +1 coming from? Where? Mid. Alright, let's try to drag on it again. Low is at 1, high is at there. We do take out the mid. The mid out of them is gonna be 22. Yeah, it's gonna be 22. It's not gonna give the answer. We're gonna move. It's gonna give more than 5. What we are gonna do is that we are gonna get the lower as mid +1. This was mid. We're gonna get this as mid +1. So now end high and low both are equal. Alright. So this is gonna be the mid. So 44 comes out to be the mid. Yeah. So now what has it to become, like what is going to be getting compared with? 44 is going to be getting compared with answer like, so nums I that is like all of the elements dividing by 44, 1 1 1 1 1 is going to give us 4. That's perfectly fine. Alright, so yeah, it's going to return the answer, that is 4. Yeah. So now, is xyz greater? Nope, it's not greater than that. So is it greater or equal to threshold? It is like not greater or not equal, but else is it less than equal to? Yeah, it's less than. So high becomes mid -1. So high becomes mid -1. But I return low, so it should be 44. Why did the loop end? This won't be helping. We have tried that. It's gonna give the right answer for that. So it wants. Alright. Well, the thing I can't understand is that why isn't the loop ending? Alright, what if I do this as like high? How about that? Nope. So the issue is that the loop should be ending, but it is not. The high and low both become this. Alright, you can't go for another iteration because then it's gonna break that thing. I mean, you will go for another iteration. You're gonna be like, alright, 44 once again. What's that gonna sound like? Alright, now my high equals to mid minus 1. So high becomes mid minus 1. Oh, there is no mid minus 1. There's only mid plus 1. Alright, let's try to figure that out with ChatGPT. What is the possible error in this code? What? If xyz is greater than threshold, like if wait, if xyz is greater than the threshold is 6, the xyz turns out to something to be 7. So I don't wait, threshold is suppose 6, xyz comes out to be 7. That was on 2. That wait, yeah, no, then let's hide this. Let's figure out if I am really wrong with this approach. Alright, so if xyz is greater than or equal to threshold, so let's try with this example only. Alright, so let's try with this example only. So we can get a sum. So if xyz is what? Xyz is nums divided by the middle element. All the elements of the nums are going to be divided by the middle element. So middle element lands at 2. Alright, so middle element lands at 2. So yeah, 9 plus 1 is going to be like 10 divided by the 2 is going to be 5. Oh, my bad. I forgot with the indexing and everything. This middle element is going to be 5. Alright, so when we are going to divide that, so when 5 divided 1, 2. Yeah, 2. So 3 ones. So it's going to give us as 5. Yeah, it's going to give us as 5. So if the threshold is greater or equal to xyz, so it's going to be giving us at 5 is going to be equal to threshold, so low becomes mid plus 1. So low becomes mid plus 1. Yeah, low becomes mid plus 1. So now it's between, now the 5, the low is basically now mid plus 1, that is 9. The high is also 9, obviously. So both are equal at the moment, so we'll run the loop again. So 9 plus 9, 18 divided by 2, it's going to be 9 only. So it's going to come as the middle element as 9. Yeah, it's going to be coming as 9. When we're going to do that, so when we going to put that into the ceil function, what we will be seeing is that in the ceil function, 9 when divided by everything, so that comes out to be less than the threshold. Alright, that comes out to be less than the threshold. Yeah, so high becomes minus 1. So it comes out to be 5. Yeah, we return low. Alright, there is some error with that condition. Let's figure that out. So when xyz, alright, when everyone divided, it comes out to be greater than the threshold, that is obviously going to be on the left hand side because the numbers are smaller right there. Alright, The numbers are going to be smaller, but in the second example they're not smaller, they're the larger ones, but that doesn't matter. I'm running a loop, I'm starting from 1 and I'm going till that. So yeah, it doesn't matter. Yeah, so I don't want to consider the smaller numbers because they're going to be giving us the bigger sums. So if xyz is greater, that means so we will be moving to the right hand side because we will be getting the numbers as smaller ones. Alright, so we have to have mid plus 1. Now I think my condition is right, but yeah, I don't know why. If the goal is to find the smallest divisors, is that the alright, let's not look at the fixes. Let's see. Oh wow. Wow. Let's see if it submits. Oh, nice. The people doing it better than mine. Oh, 1 second better, but yeah. There's some people who did that. So yeah, not to make it equal. Why not to make it equal? What's the reason? The reason is the condition should be xyz, isn't it? Otherwise the algorithm might return a divisor that exceeds the threshold constraint. Alright, we need a lesser one. So yeah, fair enough. Although I still don't understand this point completely, but okay, it's fine. But yeah, we're going to like low is less than or equal to high. So yeah, that's the issue I encountered when I was working with the 5 case at the moment. Like it came out to be equal, but it still had to run because yeah, obviously. But what's this code? High as 1000 if is divisor nums threshold, else this. If sum is 0 for I in nums, sum equals to I plus mid minus 1. If I have a mid return sum, smallest divisor int nums threshold 1 high if int mid and answer 0 while low is the divisor is this blah blah. Alright, like the same binary search approach, but yeah, me being like using some fancy terms and everything like math.ceil, math.max and everything. Not this one, that's not my code. Yeah, anyways, yeah, that's the question. Yep.